Welcome back to part 2 of the lesson today. So we're going to begin talking about multiplying rational expressions. We'll be on page 6 in the pink book. We'll be taking notes. So up at the top, in your little notes section, I want you to just copy this down. If I have a fraction, a divided by b, and I'm multiplying it by another fraction, well, what we learned back in 4.1 was you multiply just straight across, okay? So that's just a times c over b times d. Simple as that. So if I had something a little more complex, like a plus b, let's say, over c plus d, and I'm multiplying that by some crazy expression like this, well, again, I have two fractions, and I'm going to be multiplying them. So we multiply straight across. So this is going to yield, or give me, a plus b times f plus g on top, all over c plus d times whatever that is on the bottom. So instead of like freaking out when we see a whole lot of terms, actually it's pretty simple. We can treat it like one big fraction and just multiply them by putting parentheses around everything. Ta-da! It's like magic. Just put parentheses around everything, and that shows that we're multiplying them. So, for example, if I had like a 3x over x minus 5 times, I'm just making this up, x squared minus 25 all over 9. Then, instead of rewriting it all, here's my little trick for you. Just multiply them by showing your parentheses. And notice how I'm just extending the fraction line. Because, yeah, this is all really going to turn into one big fraction with 3x and x squared minus 25 multiplying together on the top, and then these two denominators multiplying together in the bottom. So have a look. The questions for this lesson will always say simplify. So remember from the last video, simplifying means we have to factor everything first. So let's see what we can do on top. I've got that 3x that can't change, but I can turn this guy into an x minus 5, x plus 5. And in the denominator, well, nothing factors. It's just going to stay x minus 5 times 9. Okay, so now what can we do? Times 9. Well, the x minus 5 can disappear because they're both factors. They're pieces that are being multiplied. And then over here, this 9 and the 3, because that's really 3 times x. So 3 is its own factor. That can simplify. So that 3 divided by 3 becomes a 1. This 9 divided by 3 becomes a 3 at the bottom. And my final answer is going to be x. So I'm just seeing what I've left up top. I have x times x plus 5 all over 3. Now, that's our final answer. There are some excluded values. Let's look back up top. What we should have done first is set the denominator equal to 0. So 9 can't equal 0, so I'm going to move on, and I'll have to exclude x equals 5. That's my excluded value. So why am I bringing up this random example? It's not even in our notes or anywhere. Well, I just want to emphasize that multiplying rational expressions is really not hard. It's nothing that we haven't done before. We're just going to extend our fraction line, put the parentheses to demonstrate, wink, wink, nudge, nudge, yeah, we multiplied them, right? And then, as always, we'll factor and then cancel. So, let's do some practice, okay? On another skill, please write simplifying monomials. Simplifying monomials. So you might want to turn to the next page in your summary section so that you can take these notes down, because there won't be enough room in your book. So please write example. let's say I have 4y to the 5th over 10y squared. Okay. In this case, I'm going to simplify not only the 4 and the 10, because I can, because they're factors, they're being multiplied. So the 4 would become a 2, the 10 would become a 5. But I can also simplify my variables here. What's really happening is if I have 5 y's being multiplied together on the top, right, that's what that is, and I have y times y on the bottom. And so notice that 2 of these get to cancel together, and we're really left with y cubed up top. So this 2 here, these y squared, they disappear, and then y to the 5th becomes y cubed by canceling. So my final answer here would be 2y cubed over 5, and that's simplified. But in general, I want to see what's going on with these monomials on the top and on the bottom. If I have x to the monkey over x to the donkey, then this will simplify by basically we're going to subtract our exponents. So we'll subtract the exponents, and then we'll write the leftover, right? Whatever m minus d, whatever the subtraction is, we're going to write that with the bigger, wherever the bigger number was. Let me show you what I mean. Example. You need to take down these. We're going to do like 3 or 4 examples, so I want you to take all of them down. If I have x to the 8 over x to the 10, well, think about this for just a second. I have 8 x's on top. X. I have 10 of them on the bottom. So when all 8 of these cancel, I'll be left with 2 x's, not on the top, but on the bottom with that 10. So really quickly, without writing it out every single time, we'll just subtract 8 and 10. So the difference between 8 and 10 is 2. But I'm not going to have x squared on the top. It goes in the bottom, wherever the bigger number was. So that means that up top, these all cancel. I'm left with 1. Not x to the 1, just the number 1. And on the bottom, I'm left with x squared. Another example. If I have x to the 5 over x3, well, this simplifies. Let's do the subtraction. 5 minus 3 is 2, and that 2 is left with the bigger number was up top. So it's going to be x squared. Now observe the difference between x to the 5 over x cubed versus x cubed over x to the 5. What's the only difference here? Well, I've switched their locations, so that means that when I cancel these, I'm going to have my x squared in the bottom instead of the top. This is going to simplify to 1 over x squared because my bigger exponent is in the bottom. So please take this down. Subtract your exponents and write the leftover with the bigger number. Try this problem yourself. 4x to the 6th over 6x to the 5. So the 4 and the 6 will cancel, and then the x's will also cancel. Go ahead and try your final answer. Okay, so 4 over 6 becomes 2/3, and then these 5x's will disappear, and I'll be left with just 1x on top, because 6 minus 5 is 1, and I'll rewrite x to the 1 where the bigger number was in the top. So that's 2/3 and x on top. Last example. Let's say I have 10x squared y to the 7th all over 20x to the 4th y to the 3rd power. Okay, so these are all factors. So all of these pieces can cancel. The 10 over 20 Well, that leaves a 1 on top and the 2 in the denominator. X squared over x to the 4th. Do the subtraction. 4 take away 2 is 2, so I'll be left with x squared at the bottom, where my bigger number was. That x to the 4th is bigger than x squared. Now y to the 7th over y to the 3rd. The difference between 7 and 3 is 4, so when I cancel, I'll be left with y to the 4th on the top, because that's where the bigger exponent is, y to the 4th, and these will disappear altogether. So my final answer is going to be, I'm left with a 1 on the top, no x's, and a y to the 4th. So I can just leave that as a y to the 4th. I don't have to write the 1 in front. And at the bottom, I have 2x squared and no y's because they all disappeared. So that's a very, very important skill, okay, how to simplify our monomials. Now we're going to put it to the test with our first example from today's notes. So on page 6, we're doing example 1a. We're going to multiply these two fractions, and then we'll simplify. But, as always, first we'll find our excluded values. So excluded values will set each denominator equal to 0 and solve. Well, y cannot equal 0. I don't really need to show much work. Y just can't equal 0 because if I do 0 cubed, that's 0 times 4 is 0. Can't have a 0 down there. Similarly, x cannot equal 0 because if x was equal to 0, I would have this guy would also be does not exist. So these are my excluded values. Now let's get into the fun part. We're gonna multiply. So, as I showed you before, we don't really need to rewrite this as x squared times 2y. We don't have to do all this work. I mean, that's right, it's not wrong. But why don't we save ourselves the trouble and just, haha, wink, wink, nudge, nudge. They've been multiplied. Good for us. Okay, now let's get into the canceling part. So since all of these are factors, I'm going to start with my numbers, okay? I have a 2, and here I have a 4. That 2 becomes a 1. That 4 divided by 2 becomes a 2. Now, I have an x squared and an x squared. Well, those cancel directly because they're identical. And now I have a y up top, a y to the 1, because the invisible exponent is 1, and I have a y cubed on the bottom. So, think about what we just learned. If I have y over y cubed, the difference is y squared. But does that go up top or on the bottom? We choose based on where it has the bigger exponent. So this would leave me with, that cancels, y squared in the denominator. So you have to show it's 1 over y squared. So just a reminder in case that didn't make much sense. If I have y over y cubed, I basically have y over y times y times y. This cancels with this, and I'm left with 1 over y squared. That's why we put our leftover with the bigger number. Great. So let's cross that one out and rewrite that as y squared. And we're done, believe it or not. Up top, we're just left with the number 1. And the bottom, I have this 2 times this 3. You can't forget about it. So 2 times 3 gives me 6. And then I have a y squared with no x's. That's my simplified version. Let's try example 1b now. So I'm multiplying these. To multiply, we just multiply straight across. So 5b minus 35 times 4b all over 6b cubed times b squared minus 49. Let's find our excluded values really quick. So we set our denominator equal to 0. Well, from this one, I see that b cannot equal 0. And from here, I can use difference of squares to find out that b cannot equal 7 or negative 7. So So this is my complete list of excluded values. B can't equal 0, 7, or negative 7. Now let's get back to simplifying. So as things stand right now, I can actually cancel this 4 and the 6, this b and this b cubed. But before I go and start crossing things out, I want to factor all the way first. So let's see what we can do. Look at this 5b minus 35. We can pull out a greatest common factor if we factor out a 5. I'll be left with b minus 7 times 4b all over. Now we're going to factor this, b squared minus 49. Well, we already did. And we know it became b minus 7, b plus 7, because we are Jedis at this. We are so good at factoring by difference of squares. And now I'm fully factored, so now we can start crossing things out. I have a b minus 7 up top. That cancels with my b minus 7 in the denominator. This 4 and the 6 both divide by 2, so that 4 becomes a 2. The 6 becomes a 3. And if I have 1b in the top, but 3, like b times b times b in the denominator, then I'm going to be left with just b squared down below. And I'm scanning to see if there's anything else I can cancel. It doesn't look like it. So what I'm left with up top is this 5 times this 2, which leaves me with 10 over, right, because I'm multiplying everything together. In the denominator, I'm left with this 3, this b squared, and the b plus 7. So 3b squared, b plus 7. And it's totally fine to leave our answer like that. Let's do one more. 1c. 2 more problems, actually. We'll do c and d, and then we'll call it a day. So let's find our excluded values as always first. So we'll set our denominators equal to 0 and see what a cannot equal. So here we can factor by difference of squares. A equals 8 and negative 8, but those are my excluded values, so don't forget to put the cross sign to show a cannot equal those. And then over here, I can't have 0 in that denominator either. I'm not allowed to divide by 0 anywhere. But in this case, I'm going to use magic x, because I have 3 terms. So there's 2 numbers that'll multiply to positive 1, negative 1 and negative 1, also add up to negative 2. So that means I have a minus 1 times a minus 1 equal to 0. So a equals 1. And I don't need to write it twice. It's just the same excluded value. So a cannot equal 1 or 8 or negative 8. I just rewrote it all as one list. Now coming back. So we've stated what we needed to state about the excluded values. Now we're going to go ahead and multiply. So that means I have my numerator times the numerator over my denominator times the denominator. Right? We've technically just multiplied it. Now let's factor so we can start simplifying some things. See if you can actually pause the video and try factoring. Actually, all 4 expressions can factor, okay? So try factoring it yourself. Okay, so from a squared plus 7a minus 8, I would get a plus 8 times a minus 1, and that would be from magic x. For 5a minus 5, I would get 5 pulled out and an a minus 1 left over. From a squared minus 64, I would do difference of squares. And by the way, we already did that factoring over here, right? And then from a squared minus 2a plus 1, I would get a minus 1 times a minus 1. which we already did that work over here. Another way you could write that is a minus 1 whole squared, since it's just being multiplied by itself. Doesn't really matter though. We're good. Okay, now we're fully factored, so we can cancel things out. This is the fun part, right? So I have an a minus 1. Oh, darn. Okay, that was a mistake. So I have this a minus 1 that can go with this a minus 1, right? Oh, and then I have a second a minus 1 that can cancel with that one there. And then we have a plus 8 that cancels with a plus 8. And we're done. That's all we can do. So our final answer leaves us with a 5 in the numerator and just a minus 8 in our denominator. But, of course, a cannot equal 1, 8, or negative 8. All right, last problem. Let's find our excluded values. Try to do it yourself. As always, set the denominator equal to 0, solve. So for this piece, we'll use magic X. And those numbers, you have to be careful here. Multiply to negative 6. That'll be 6 and 1, with the 6 being negative. 2 and 3 don't work in this case, because then you would get a positive 6 when you multiply them. Anyway, so negative 6 and 1. So I get x equals 6 and negative 1, and these are my excluded values. And that's just for this part. We have to also make sure, just by looking at it, we can tell x cannot equal 0. Right? If we set that equal to 0, we could solve and say x cannot equal 0 either. So these are our excluded values. Now we're going to multiply. Let's multiply. So I have x squared times 6x plus 6 all over this times this. Okay, just by looking at it, you can see that the x squared is going to cancel with this x squared. But before we cancel things, we like to always be consistent. So we're going to factor first. I have x squared times, and here I can do greatest common factor, and here we'll do magic x. So pulling out the greatest common factor, which is a 6, I'm left with x plus 1. And we actually already did this work on the side. That becomes x minus 6, x plus 1. And then 3x squared does not factor. We just leave it like 3x squared. And now we're ready. So let's find our common factors. Up top I have 1, 2, 3 factors. In the bottom I actually have 1, 2, 3, 4, because right, it's 3 times x squared. Just good to keep in mind. So let's cancel the common factors. Bye-bye x squareds. Bye-bye x plus 1. What else? 6 divided by 3 leaves me with 2 over 1. And now we're ready to write our final answer. I'm left with the 2 at top, and in the bottom, just an x minus 6. Provided, of course, that x cannot equal 6, negative 1, or 0. We're done. So for your homework, part 2, we're going to be on page 23. So your homework, I'm just going to stop the notes here. Your homework, in addition to finishing up page 21 and 22, is going to be page 23. And I want you to do number 1, 2, and 3. Here's what you'll do. Since there is an A and B per section, just that totals to 6 problems. Total, right? You have number 1 A and B, number 2 A and B, and number 3 A and B. but I just want you to choose 5 of them. Okay, so your homework is page 23. Choose 5 of those 6 problems. Okay, we're done. Bye.